Okay. Okay, so for today, I need you to have out your science notebooks and something to write with, and open up to the page where you've been doing your science starters, your warm-up questions. Okay, Rob, can you flip it to the page where you're doing your warm-up questions? Right over here. Perfect. All right, so for today, it's okay if you're thinking about this with a partner, but I want you to spend at least 30 seconds working by yourself before you start asking your friends for help. We're going to be making a spider diagram that is about the water cycle. So I know we haven't talked about it yet in class, but I know you've learned about it before. So go ahead and write water cycle in the middle, put it in a circle, and then start making your spider diagram with anything you can remember about it. Okay? And after about 30 seconds, I'll let you know, and then you can start working with your friends if you want to. Yeah, you can totally use your resources around the room. That's fine. How's this one related?
Because, Miss Maida, it gets in the water and they have to treat it.
Okay.
And so isn't that a part of the water cycle when stuff gets in the water?
Okay, I
And
see
then
where
when
you're
it goes to
thinking is.
evaporate, yeah.
Okay, okay. Okay, try to get down a couple more thoughts before you start working with each other. And remember, if you have, like, Taylor, can I use yours as an example?
Sure.
So like how Taylor did here, where this one reminded her of something else, you can have extra branches coming off. Remember that.
Okay.
It's okay if you don't, but if you do have them, that's okay to do. That helps me see your train of thought. Okay, if you want to compare it with a friend to see if you can get any more ideas, kind of talk it out, now's a good time to do that. You've got about 2 more minutes left before we're going to be done. See how much stuff you can remember.
Okay, what'd you put?
Poop. Rain.
Okay, no.
No,
All
it
right,
gets
take
in the
this
water.
seriously. So
Or you're
I
like,
have,
rain. Okay.
I have snow, rain, clouds, rivers, trees. What do you have, Rob?
Percolation.
Nice.
I
That's a
have
big word.
transpiration. Evaporation.
What's that?
It's where things transpire.
How do you
I have
spell that?
osmosis.
What's osmosis?
we're going to come back to all these vocabulary words in just a second.
Okay. Transpiration.
Transpiration.
Is that when you sweat?
Oh, that's perspiration.
Oh.
Okay, does everybody have all their thoughts on their paper?
Yes, ma'am.
Yes.
Cool. All right, so who can share with me by raising their hand? We don't even know what you're going to share. Maybe I want you to share your deepest, darkest secrets. Okay, Ryan, can you share with me something that you put down other than the one we already talked about?
Okay. I put down evaporation.
Okay, can you share with everybody what evaporation means?
It means when water goes from its liquid form into its vapor form.
Awesome. Can somebody else share with me what that might look like in the water cycle? Like what would be forming after that?
Well, when the water evaporates, it turns into a cloud.
Yeah, so when it evaporates, it goes up, and then what's that other vocabulary word for it comes into a cloud? Does anyone remember? Think way back.
Condensation.
Condensation. Awesome. Your guys' elementary school teachers are going to be so stoked that you remember all of these vocabulary words. Great job, team. Okay, so as we go on, we're going to learn a bunch of more words about it. Does anyone else have any other vocabulary words they remembered that they want to share?
No.
Maybe they remember the word, but they don't know what it means, and then our friends can help them out about it. Rob, I see a word that you wrote down. What's this one?
Percolation?
Awesome, yeah. Do you remember what it means, or is it just a nugget in your brain from before?
Just a nugget in my brain.
Does anyone remember what percolation is?
It's this coffee maker.
Does anyone remember what percolation is in relation to the water cycle?
So it means like when the water gets into the ground, the water runs through the ground and it percolates in the soil.
Yeah, perfect. So when it's like seeping down into the ground. So where would things... Where would things... Can we make sure that we're being kind and helpful? So when water percolates, where does it end up? Yeah.
Rivers.
If it could end up in a river, but what if it percolates from the river?
Ocean?
An underwater
ocean.
aquifer.
An underwater aquifer! Yeah! Crushing it! Look at you go! Okay, so, beautiful. Now that we have our brains kind of in the right place, we are going to flip to the next page of our notebooks where we have a table that we put in there yesterday. And it has a big fancy word at the top. Can someone tell me what that big fancy word at the top says? Sound it out. Ryan? would you like to-
Hydrologic.
Hydrologic. Awesome. So, you probably, has anyone heard the word hydrologic before today?
Yeah, I think
Yes,
it's a Pokemon.
No, I mean,
That's not a Pokemon. Do you need to take a walk? Take a quick break? Breathe?
anyway, it comes from the Greek. We have two Greek Latin words here, right? We have hydro, meaning water, and logic, logos, meaning the study.
Good job. I'm not sure how this 6th grader knows about the Greek root words.
I have extra school at home.
He's gifted and talented.
I can see that.
You should read his
he has an
IEP.
IEP.
Okay, stop it.
Sorry. Alright.
Yeah, so hydrologic cycle is actually the fancy pants scientific word for the water cycle. So if you're like, what, the hydrologic cycle? I thought we were learning about the water cycle today. I already knew that one. Good news. We're just going to build a little bit deeper on that water cycle that you already knew. So when we talk about it in class and we say hydrologic cycle, that's what we're talking about. So we'll add that to the vocab section of our notebooks a little bit later. Okay, so what you have in front of you, somebody, Taylor,
Yeah.
read that whole title at the top.
Hydrologic cycle travel log.
Perfect. It is a travel log because we are all going to magically transform into water molecules. It's going to be
Is it
awesome.
gonna hurt?
No, maybe a little. So we're going to transform into water molecules, and we are going to travel through the hydrologic cycle in this classroom.
Time and space.
All
This
of
is
it.
so cool.
So that's what we're going to do today. The way that we're going to do it, you guys are going to work in small groups of 2 or 3. Perfect. Yeah, I love it. You can work with your table groups.
Did you go over your shirt here?
Oh, gotcha.
Are you ready to listen to instructions?
Yeah.
Okay. So all around the room, there are signs, not this whiteboard up here, but there are signs like this. And at the top of them, they have a location that water might be at some place in the hydrologic cycle. And then they have some words underneath. Okay? Who can tell me an example of a place that water might travel to in the water cycle? Ryan.
River.
River. Rob, do you have another one?
Lakes.
Lakes. Awesome. Taylor, do you have another one?
Soil.
Yeah, perfect. So there's all different places in the water cycle, and you're going to see even more. There's 9 different stations. And they're all over the room. I promise anything you roll is going to have a station. Underneath, you'll see the numbers 1 through 6. I'm going to give your group some dice. And obviously, they have 6 sides, right? So you'll roll the dice. Let's say you started at Glacier. And I rolled the dice. Rob, would you like to roll the dice as my example?
Yeah.
Awesome.
1.
You got the number 1. So I would look at Glacier. I would look at what number. And then I would read that station. And that's where I would go next. Okay? So the way we're going to fill it out on the log, we're going to do our first station together to fill it out so that we understand what we're doing. But you're going to pick where you're going to start. Where it says location, you're going to write it there
1.
on start.
Glacier.
So this will actually work better if we can see the signs instead of sitting at our table. So if everyone could stand up, grab a dice, grab your group, and go to whatever station you want. Let's start with Glacier.
Got your name on this perhaps.
Yeah, I got $2 on
Take
that.
it seriously.
Okay,
Glacier.
so if you're at Glacier at the start,
Glacier down. Work like this is Glacier.
so write Glacier on your log where it says start. If you need to grab a hard surface because your notebook is floppier than normal today, that's fine.
Glacier.
Okay, now Rob already rolled the dice. Do you want to use Rob's roll or do you want to do a new one? I'm going to write it where it says start.
What?
So one more time, find the square where it says start and write Glacier. Yeah, just like Taylor did.
Is that the example?
Very confused.
Alright, so
Not
roll the
easy.
dice again.
So roll the dice. You got a 1 again. So now on the next one, the place you go next
Is a glacier.
is a glacier. So you're gonna write 1.
I should never
You'll write
scratch that
glacier again.
out. Glacier again?
Here's what this is.
Oh, nice.
Glacier. Is the camera?
And now, Rob, yeah, the camera's gonna move.
You're gonna blur my face out of this room.
Stop it, please.
So what do I do now?
Just wait.
I'm trying to figure out how to flip this around, but I don't know how. So, Rob rolled a 1. That means we stay at Glacier. This is kind of a funny example, because we're actually staying in the same place. But what you're gonna do, can someone read to me what the second or the third column says at the
How
top?
did you end up here?
How did you end up here? So what you're gonna do with your group is you're gonna think critically about how the water might have either traveled to that new location or why did it stay in the same place? So what could have occurred in the ecosystem that made that water either move to a new location or stay in the same place? So I want you to think for a second.
Global warming.
Yeah.
And does anyone have an idea about why glacier would stay, why that water molecule wouldn't leave the glacier?
If it was cold enough, it would stay frozen.
Yeah, maybe it was really, really cold. So it stayed frozen in the glacier. It wasn't warm enough to melt, to do runoff, or to evaporate. And you'll write that answer right here
Stayed frozen.
in your log. Yep, stayed frozen. That's perfect. If you have an answer where you know a vocabulary word that you've learned before and you want to write that down, you can. If you want to explain it in a phrase or a sentence, that's okay too. But what I'm going to challenge you guys to do is try to think of as many different answers for things as you can. Sometimes you're going to repeat the same answer more than once, but try to think critically if there's more than one thing that could have happened, right? So if you get, if you've already said ran off into the river one time, try to think of specific reasons of how that could have happened, right?
So we roll again.
Now you roll it again. Does everyone understand how to do it?
Yeah.
Okay.
4.
4.
Groundwater.
Groundwater.
That's
we
where we
go.
go now.
So location. So number 2 we put groundwater.
Uh-huh.
Yeah, and then we go over to the other side.
Where's find groundwater? Nice. Okay.
And remember, I want you guys talking as a group. That's why we're working in a
So
group.
now we have to. How did it get from a glacier to the ground?
Yeah.
It melted.
How did it?
Wait, but like how?
It melts and then it goes down into the groundwater.
From a glacier?
Yeah.
But there's no ground. at
Like a
glaciers.
mountain glacier.
Yeah.
A mountain.
No, we're
Did
not talking about
glaciers always
icebergs.
live
Glaciers are on the
In the
land.
poles?
in the...
Okay, so the water melts.
But deep
Into the soil. And then it goes from the soil.
Are there still glaciers around?
Yes, there are.
In
Outside
Alaska?
of the poles? Where's
Yeah.
the closest glacier?
To
Alaska.
here? No, Montana.
They used to be way bigger though, right?
Yeah, it used to be way, but they're still there.
So water melts into the soil and creates groundwater.
Water melts.
And then, Rob, do you remember what that
Shoot.
vocabulary word you wrote down was that talks about how it gets down there?
Percolation.
Percolation, yeah. So if you wanted to add that word, you can. If you don't want to add it, you don't have to. It's okay. It's okay if you guys all have the same answers written down, but it's okay if you have different ideas and they're different as well.
No.
Okay.
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 Roll it. Roll it.
Roll the dice. 4. Groundwater.
Okay.
So we stay at groundwater?
Yeah. So why did the groundwater stay?
Because it wasn't pumped up by a farmer.
There's no percolation occurred.
Well, no. So, okay. What would stop the groundwater from
Oh,
getting
a
into
dam.
aquifer?
No.
No.
What would stop groundwater from getting out?
Yeah, like why
A
would the
clay impermeable layer.
Beavers?
Oh, yeah. What do you mean by impermeable layer, Ryan? I like where your
Impermeable.
thought is right now.
what does that mean?
So, if you have a big, if you have a clay strata below there that's dense enough, what's going to happen is the water is going to go down and it can't penetrate that strata, and it's just going to move laterally across that strata until it can find something. It might pool there. There might be a dip in that clay cap that causes it to pool there, but if it can't penetrate, it still has to get out.
Yeah. That's a great
That
idea.
makes sense.
So what do I write down?
So pretty much like what he's saying is that the water it goes down, but it could get like trapped by a layer that like the water can't get all the way through.
Water.
So it has to travel
can't
or stay or like pool.
get through layer of earth.
Yeah, that was a really good explanation, Taylor and Ryan. So Rob, do you understand what would happen to the soil if it couldn't get through? Like what kind of layer that might be?
A strata.
Okay, but what does strata mean?
A layer.
Yeah, a strata is a layer. So if you had a layer of tiny little pebbles and I poured some water on it, what would happen to the water?
It would go to the bottom.
Yeah, it would go to the bottom. Now, what if I had some like really thick clay in a jar?
It would stay on top.
It would probably stay on top, right? So if at the bottom of where the groundwater was in that aquifer, if it was little tiny pebbles, would it keep sinking?
Yes.
What if it was thick clay?
No.
Yeah. And then would it have to get stuck there?
Yes.
Yeah. Do you understand?
Yes.
Alright, let's roll. 6.
Great.
Groundwater! Okay.
We're not moving a whole lot.
So we stay here again?
Alright, now we have to think of another reason. What if...
The aquifer is full. You can't. The aquifer already has too much water, and it can't penetrate because it's full.
So, like, there's been a lot of rain that year or something?
Well, then where does it go?
Just hangs out in the soil.
It just stays.
It sticks in the soil.
So, kind of like, okay, so like when you're at the lily pond and all that water is in the ground right there
Mm-hmm.
and never leaves, is that groundwater?
Yeah, it's spring water. So that's coming up from a. There's no aquifer under this granite cap, so it's essentially just a fissure where water is coming up in the granite.
So we could just say there's too much water and so it just stays
Yeah.
there.
I love how you made a personal connection.
Thank you, Miss Maida.
You're welcome.
I'm afraid everyone here thinks I'm a nerd or a teacher's pet, though.
Well, in this classroom, we don't use that kind of language to talk about each other. And
Thank you.
we're all part of a community
I agree.
where we help each other out.
Agreed. All right.
Okay, roll something that's not groundwater.
I want to roll.
1, 2, 3. 4.
Groundwater. Still at groundwater. Man, this is like.
Groundwater again?
Yeah. Okay.
Okay, so groundwater, we have impermeable layer overcharged aquifer.
What if?
Sure.
What if? So let's say the water, it's in the ground, and then it freezes, and it stays there, and then in spring it melts and it's still there. Does that make sense?
So it's permafrost that doesn't ever
Evaporate.
doesn't get yeah, that would be.
Yeah, that's awesome. So if it changed states, it would get stuck there. That makes a lot of sense. We're also going to only do 10 steps instead of 15, everybody,
Oh, okay.
for time.
It could be recaptured, right? Let's say it's in the ground because it's like going to an irrigation ditch to go. Like, what if it's
Oh, that's a good idea.
if it's just transiting,
Yeah.
like under in the ground.
Mm-hmm.
Three.
Yay, lake. Over there.
Okay. Going to the lake.
All right. So how would the water get from the ground to a lake? It just comes up, right? Just goes.
It could, spring. It could come up.
Comes up through spring.
Like. What is spring water, anyways? It's just water that comes up from the ground.
Again, you could have a transit from a. It could be something that's runoff that doesn't actually surface.
Okay.
So it's you still have it's just in transit.
Where's the dice at?
I guess.
Okay, roll it.
Where'd you roll? What was it?
4, river.
Oh, this is easy.
River.
Lake to a river.
Released from a dam.
Oh.
Natural topography goes from lake to river.
Can you explain that though? Because you're just saying stuff.
I thought we only need to do one.
Yeah, we only need to do one.
Oh,
Yeah,
who's the
so
overachiever now?
We only need to think of one for each, but make sure with your group, remember, it's okay if you have the same thing written down. It's okay if you have different things written down. But make sure that anything you have written down in your notebook is something that you understand what it means.
Okay, so I'll just write down that first thing and not that second thing.
Mm-hmm.
It's the same thing though. Natural topography means like for a non-artificial lake, let's say you have a mineral, you have a formation that is hard for the water to penetrate. Let's say you have a granite formation, and then it just rivers out, and so you don't necessarily have to have a dam.
I see what you mean. Very cool.
Very sick.
All right. Roll the dice, Robert.
You got a boss. 4. River.
Did we move to the river after the last one?
No, we didn't.
Oh!
So we're on river. Where's river at?
I don't know. Could be
Wait.
anywhere in this room.
Ah!
Wind River.
That's a casino.
It's also a movie.
Yeah. Pretty sad
Sad
movie.
movie.
So you,
About
river?
missing and murdered
Find
Indian
river?
women, yeah. All right, roll again.
Okay, 4. 2. River. 1.
Clouds.
Yeah! I know this one. Evaporation. So it heats up, evaporates, and then condenses
We gotta go with the cloud.
into clouds.
Perfect.
On to the clouds.
Oh shoot.
Found it. 3.
Like
Lake.
Rain.
Rain. And clouds? Where are we at? Oh.
Wait, what? Rain?
rain. Okay, now
We're at a lake.
we're at lake, and now we're going to whatever 6 is.
Lake.
Lake. How did it stay in the lake?
More rain.
It was on the bottom.
Well, remember, it's your one drop of molecule, right? So would more rain make it stay?
Yeah.
Would it, though? What do you mean by more rain? I'm asking Rob to elaborate on his thoughts. I'm not sure I'm understanding his thinking.
Is there, it's a hot summer day and there's evaporation that turns into clouds and then it rains back into the lake.
Oh, so you're saying the same molecule got evaporated up and then rained back down.
Yeah.
Okay, yeah, that could happen. And then it could also have stayed. What were some other reasons that I heard?
Like it's the bottom layer water.
Yeah, definitely. So lakes are really big, right? It's not a tiny little puddle where it's all going to evaporate every single day. The whole lake doesn't disappear and come back. So it could have been at the bottom and it was just too deep. Okay, did we reach 10? Yeah.
Are we done?
Yes, we reached 10.
We reached 10, so we're all
did it.
done. We're going to come back to our desks.
Raise your hands. Or fingers.
Okay, so what I need you to do is we're going to tally up how many times we were at each of the stations. And I'm going to write up here so we can all see as a class how we did. Okay, so what I need is for one person from each group to tell me how many times you ended up in a glacier.
2.
Taylor.
You have to raise your hand, Rob.
Awesome. Thanks for raising your hand. Rob, do you want to tell me how many times you were at groundwater?
4.
Wow, that's a lot. Okay, did you ever make it to animal?
No.
No.
Okay. What about the lake?
3 times.
Awesome. You didn't raise your hand.
I don't have to. It's in.
He did not raise his hand. You're right. That is not very fair.
That's not
Okay. Taylor, did we end up in the ocean?
No.
Taylor, did we end up in the ocean?
No.
Ryan, did you end up in the clouds?
Yeah,
How many times?
one time.
Stay in the clouds.
Rob, did you end up in the river?
Yes.
How many times?
Once.
Okay, Taylor, did you end up in plants?
No.
And Ryan, were you ever at the soil surface?
No.
Okay, so I want you to look at our class data and see if you notice any patterns or observations. Does anyone have any thoughts about it?
Yeah, we ended up.
Taylor, thank you for raising your hand.
We were at groundwater a lot.
Yeah, you're at groundwater a lot. Can anybody think of any reasons why you might be at groundwater a lot?
Because there's a lot of water in the ground, and that's where a lot of groundwater doesn't change state.
Isn't that like where most of the water is?
We mean
Underground aquifers.
Yeah, so we'll actually tomorrow, awesome connections to tomorrow, everybody. We're going to talk more about aquifers and the way that water is distributed on the planet. So how much water is in each location. Oceans have a lot of water. Glaciers and like the ice caps have a lot of water. But there's a ton of water in the groundwater. So that's actually where a lot of your water is going to be hanging out. So if there's a lot of water there, it probably doesn't leave that often, right? So it makes sense you'd have it a lot. Any other patterns that we notice or any other observations, questions, thoughts? Ryan?
we never ended up on the soil surface.
Yeah. Can somebody who hasn't shared yet think of a reason why some of these... Can anyone think of a reason why soil surface plants or animals might not have had any in this
Climate
cycle?
change.
Can you explain why you mean climate change?
Because there's water that's not getting to certain places anymore because our climate's changing.
Yeah, that could definitely
So,
be a part
droughts.
of it. That's a really good connection to human impact. And then for animals and plants. So for animals and... Yes, Ryan?
There's just not that much water in them.
Yeah, there's not that much water in the animals and plants, right? And do you think it stays in them for a long time, or does it go away pretty quickly?
They pee it out.
Yeah, so animals, every animal pees, right? So if it's alive, it pees. If it's an
That's
animal,
why I put it.
I don't pee or poop.
everybody poops, even Beyonce. So everything that drinks water has to pee it back out, so it doesn't stay in their system for that long.
And then
So
it goes
it's
back
always
into the
cycling.
ground, huh?
It does, just like Mufasa taught us. It's just like the circle of life.
It's a line.
Okay, so we're almost done for today. What you're gonna do is you're gonna get out a piece of paper to write your exit ticket. On your exit ticket, just like always, I want you to put your name, the class period, the date, and I want you to do this one question that is on the whiteboard, and that is, you can choose. You can either draw a picture, or you can write an explanation. I want you to create a model of one example of how water could travel through the hydrologic cycle. I want you to include at least 5 steps. Okay? Does anyone have any questions? And remember, for our exit tickets, we're being graded on just a couple of things. That we answered the question, that we followed directions, and that we put in effort. If you can do those 3 things, then you'll get all the points.